Hello dear friend, welcome to Olympiadia channel. My name is Hossein Mardani and today we have a straight question. How many regions we can get if n straight line intersect each other? So sometimes we can intersect in this way that we can get most regions as possible. So if we have n straight intersect, which is n is equal or greater than 1, we can get some regions on the whole page. So let's count the whole regions we can obtain from these n straight lines. So let's read the question. How many maximum regions are formed by n straight line in the whole page? So let's try by 0, 1, 2, and 3 line and get the sequence of regions. So here, first of all, we have a whole surface which is clean and nothing line is there. When the number of lines is 0, we have one region. The region number is 1. So we can write in the up right side the total regions as 1. When we have one line, the line cross over the page and divide the whole page into two sections and two regions. So we can get two regions in whole the surface. And when it comes to two lines, we can draw it in two different ways. In one way, we can draw the second line as parallel as first line. So if we have the second line as parallel, we can get three regions. But what happens if I draw the second line in the way that intersect the first line? So in this way, we can get four regions. So the maximum regions is when the second line intersect the first line. So we have in two lines the four regions as most as possible. So it's better to intersect the lines together. And in the three line, we can three different way to draw the line. We can draw the line in a way parallel of each of the line, or we can pass it at the intersect point of two line, or we can pass it in non-intersect point of two line. So if I pass the line in a way that go through the intersect point of two line, we can get 6 regions maximum. But if I don't pass it through the intersect point, we can get maximum 7 region. So it's better to pass it the point that's not the intersect of two line. So we can understand that it is better that pass each line from non-intersect point and non-parallel to each line of the page. So we can go through and write all the information inside a table. So if I have 0 line, 1 line, 2 line, or 3 line, we can get respectively 1, 2, 4, and 7 regions. So what if I have n lines? We can get the pattern of regions increasing. So if I go through 0 line to 1 line, we have one increment in the region. And if I go through 1 to 2 line, we have two increments in region. And if I have three lines, we have three increments in the region. So it is realized that if I have n line, we have n increment in the regions. So the region's number is 1 plus 1 plus 2 plus 3 plus etc. plus n. So the pattern is 1 plus the addition of the number of 1 to n. And we can get the pattern as here. If I have n lines, we have the region's number as 1 plus 1 plus 2 plus 3 plus until n. And we can get the explicit formula for this. This is 1 plus n times n plus 1 divided by 2. And we can get the final number as n squared plus n plus 2 divided by 2. Or we have just another level left. We have to prove if I have n lines, we have maximally n squared plus n plus 2 over 2 regions. So we can get it using mathematical induction theorem. So in the mathematical induction, we have a proposition. Proposition said that if I have n lines, the regions is equal to n squared plus n plus 2 divided by 2. So we have to prove that if I have one line in the first level, if I have one line, the region's number is equal to 1 squared plus 1 plus 2 over 2, which is true because if I have one line, we have two regions, and the formula is simplified by 2. In the first level, we assume that if I have n lines, the regions is n squared plus n plus 2 over 2. And we have to get the result if I have n plus 1 region, if I have n plus 1 lines, the regions is n plus 1 squared plus n plus 1 plus 2 divided by 2. So we have to prove that. Assume that we have n lines. So the regions is n squared plus n plus 2. Now we are drawing n plus 1th line. So the n plus 1 lines have n intersect of n another line. So we can assume that first, second, third, and nth is the intersect point of each line. So we can draw it by randomly. So we can count the new region of this new line. The new region is here. First, second, third, n, and n plus 1th regions. So we have n plus 1th new region. So we just need to add n plus 1 region to n regions of the assumption. So if I have n plus 1 line, the regions is equal to n squared plus n plus 2 over 2, which is the regions of n lines, plus n plus 1, which is new region we can get in this level. So the overall regions we can get is equal to n squared plus n plus 2 over 2 plus 2n plus 2 over 2. We can calculate the final and get n squared plus 2n plus 1 plus n plus 1 plus 2, which can be get as n plus 1 squared plus n plus 1 plus 2 over 2, which is the proposition we claim that we have to prove it. So the proposition have been proved, and the proposition said that if I have n lines, the regions are maximally n squared plus n plus 2 over 2. So the maximum regions is as here. Okay, we approach to end of this video and we can get the answer. I hope you all students enjoyed this video, and until the next video, stay tuned and goodbye.